Fortunately, I was one of his students in Kolkata University in the late 1970s. In our first semester, he used to take classes on physical oceanography and elementary cartographic methods. He was so particular and so detailed that I can still remember his classes on oceanographic research, methods, properties of ocean water, and especially the TS curve and its interpretation. He taught us the mathematics of how to find the temperature and distinctively different properties, and so on. He could simplify any principle through algebraic and trigonometric expressions. As I had physics and mathematics as subsidiary subjects in BSc Honours, it was really a revelation to me. In class, he was very gambhir, never smiled, and was very serious in teaching and elaborate board work. His precise drawings with chalks of multiple colors made the subject easier to understand. His precision was remarkable when he drew circles, ellipses, parabolas, hyperbolas, or straight lines and arcs. His last class drawings are still there in his chamber in the Department of Geography, University of Calcutta. Another of his teaching conduct, rarely found these days, is that he was punctual in class with clinical precision. Not a second late, always well dressed and smart attire. In cartography special paper, he taught us spherical trigonometry, finding parameters of distance, azimuth, rectangular, and polar coordinates of locations in equatorial and oblique cases of azimuthal, cylindrical, and conventional map projections, with so much elan that I never found it complex and tough. I admired him the most. As a person, I never saw him socialize, even with his dearest students. His walking pace was that of a military personnel, and his laboratory drawings was geometrically precise, with the best design and layout, stencil, aerograph, rotring lettering, and symbolization. And we faced great difficulty in getting our laboratory notebook signed, which he never did if he was not satisfied. And he kept records which one of the whom he signed. Basically, he made us follow all the 7 principles of cartography. Today, I feel sorry for myself as he wished that I do my PhD research under him in the 1980s, but I did not. And finally, my first endeavor of PhD research on map projections under another teacher had to be abandoned in the in the final stage, because of not me, but my then supervisor. I'm sorry to say. After several years, I enrolled under Professor Bireshwar Banerjee, DLEAT, Calcutta University, and was duly awarded with PhD degree within almost 3 years. In the process, I lost my 7 valuable academic years in life, which cost me my first promotion also in education service. I had always a close contact with Professor Betal, even after his retirement. When I invited him to take PG classes at Presidency College in the early 2000s, he promptly joined and became very popular among the students. On this occasion, I pay my deepest sense of respect and gratitude to him, whom I follow as a teacher and supervisor. He came from a very educated family of Mahishadal, Purbo Medinipur, and was deeply associated with the Geographical Society of India, SARC of India, NATMO, INCA, and many others. He has quite a large bouquet of research publications and supervised PhD research for a long list of scholars. Today, after his demise, quite a large number of awards after his name have been introduced in several premier academic institutions in India. And I am taking this opportunity to propose to the authorities of this department annual award in the form of certificate to be given to a student with cartographically best designed laboratory notebook and dissertation. Now, on to the topic. Can you identify this man? He was born in Cyrene, a Greek colony, now the city of Shadat, Libya. As a young man, he was educated at the academies of Athens. He was a brilliant student and made such a name for himself in scholarly endeavors that in 245 before Christ, the Greek rulers of Egypt brought him to Alexandria to tutor his son. When the chief librarian of the Great Library of Alexandria died in 236 BCE, he was invited by Pharaoh Ptolemy III to take his position and run it. He was excited and accepted the offer at the age of almost 40 plus. While serving there, he wrote a comprehensive treatise about the world, which he called Geography. This was the first use of the word, which in Greek means writing about the world. This man is Eratosthenes, the pioneer who made the first attempt to describe our earth through geodetic measurements and cartographic visualization. And he is the man because of whom we are all here. His map of the known world was the first of its kind, featuring a grid of parallels and meridians used to estimate distances between different locations. He introduced the concepts of torrid zone, temperate zone, and frigid climatic zones. His original geography was in 3 volumes. The first book contained a summary of existing geographical work, including his own speculations about the nature of the planet Earth. He believed it was a fixed globe whose changes only took place on the surface. The second book described the mathematical calculations he used to measure our Earth. And the third book contained a map of the world in which the land was divided into different countries. It is one of the earliest examples of political geography indeed. He designed a system for finding prime numbers. That is the whole numbers that can only be divided by themselves or by the number 1. This method, still in use today, is called the sieve of Eratosthenes. He was also the first to calculate the tilt of the Earth's axis, which he figured with remarkable accuracy. The findings was reported by Ptolemy. He also computed the distance of the moon and the sun from the Earth, but with less accuracy. He made a huge catalogue of 675 stars. He made a calendar with leap years and laid the foundation of chronology in the Western world by organizing the dates of literary and political events from the siege of Troy to his own time. Most Greek scholars, by the time of Aristotle, agreed that the earth was a sphere, but none knew how big it was. It was Eratosthenes who was the first geodesist to measure at least one parameter about the shape and size of the earth, that is, the circumference of earth. He computed this by using simple geometry and trigonometry and by recognizing earth as a sphere in space. He heard about a famous well in the Egyptian city of Soinet, now seen in Greek, now in Aswan, located very close to the Tropic of Cancer on the river Nile. At noon, one day every year, the summer solstice between June 20 and June 22, sun's rays shone straight down into the deep pit that illuminated only the water at the bottom, not the sides of the well, as on other days, proving that the sun was directly over it. He erected a pole in Alexandria and on the summer solstice noon observed that it cast a shadow, proving that the sun was not directly overhead but slightly south. Recognizing the curvature of the earth and knowing the distance between the two cities enabled Eratosthenes to calculate the planet's circumference. A century later, Eratosthenes, a Greek astronomer Posidonius of Rhodes, calculated the Earth's circumference using the star Canopus as a frame of reference. When the star is visible on the horizon at Rhodes, it is 7.5 degrees above the horizon in Alexandria. His first calculations came out almost exactly correct, but he revised his distance between Rhodes and Alexandria, which resulted in a number close to about 29,000 kilometers, something like 28% smaller than the actual circumference of the Earth. Ptolemy reported his computations, and Christopher Columbus used it to convince his supporters that he could quickly reach Asia by sailing west from Europe. Mind that, a blunder of 29,000 kilometers. This was the blunder on Columbus's part. Had he used Eratosthenes' figure instead, he would have known that he was not yet in Asia when he landed in the New World. Thus, Eratosthenes was a polymath, nicknamed Pentathlon, and a librarian, geographer, mathematician, astronomer, historian, and also a poet. A crater on the moon has been named in his honor, Eratosthenes crater. Fundamentally, the discipline of geography seeks to classify phenomena, to compare them, to generalize them, to ascend from effects to causes, and in doing so, to trace out the laws of nature and to mark their influence upon man, thereby simply making it a description of the world. Hence, geography is a science, a thing not of mere names, but of argument and reason. Here are some pictures of the great philosophers of different historical periods. Aristotle believed that geography is a very important subject in the real world because it helps to avoid the errors of other people and countries and to profit from their good ideas. Aurelius opined that geography is needed to keep our principles of living with nature alive and compare them to those in other countries. Montaigne elaborated that geography teaches us to put things in perspective amid earthquake, volcanism, floods, and wars. Cervantes asserted that it is the job of a geographer to be exact, truthful, and unbiased about time, a storehouse of deeds, witness for the past, examples, and counsel for the present, and warning for the future. Descartes emphasized that geography is essential to judge our customs and actions better by examining those of others living in different situations. To travel to another place and time by listening to people describing their time and country. Pascal believed that man makes continual progress through trial and error and finally learns the universal principles of human nature by seeing man in different kinds of situations and circumstances. To Hume, mankind is so much the same in all times and places. The use of geography is to understand, live, and exist in our current world. We must trade, understand, and exist with others. Adam Smith, on the other hand, said that geography is essential to ensure order in society by having informed and educated people in order to remove prejudices and increase understanding. We largely lack this kind of thing, and that is why several social conflicts are very much abundant this time. This is Peter Haggett. Peter Haggett viewed geography as a modern synthesis that fascinates to take us to a different land and people with different cultures. It is about 5 fundamental elements. Number 1, location, that is position on the Earth's surface. Number 2, place, physical and human characteristics. Number 3, relationships within places, that is man-environment symbiosis. Number 4, movement, human interaction on the Earth. And number 5, regions, how they form and change. Hence emerges two fundamental branches of geography. Number one, the study of earth in relation to man. It concerns the domain of physical geography by embracing the domains of earth science, atmospheric science, and life science. The core principle of these are based on rigid hypotheses, theories, and universal laws of physics, chemistry, and mathematics. Number two, the study of man in relation to earth that concerns the domain of human geography. It entwines the domains of economics, philosophy, sociology, and demography. We, the geographers, believe that regularity of features over the Earth's surface that can be defined, identified, and analyzed with a scientific understanding of the geographical knowledge. It is this that forms the philosophical foundation of the discipline of geography. Naturally, a geographer discovers this spatial order to identify the order forming processes, to comprehend and model its operational mechanism, and finally to examine the order forming factors for a scientific geographical explanation. You know, Galileo, one of his doctrines, measure, measure, and measure the differences of the differences of the differences. It is one famous Galilean doctrine, and this probably summarizes the philosophical basis of the discipline of geography that comprehensively deals with the description and explanation of the areal differentiation of the Earth's surface. With Galileo, next man is hard-shouldered. The first part of this statement, it concerns how one should study phenomena. It includes the cognitive description and explanation. Thus, it refers to the methods of geography. The second part concerns what one should study. It identifies thereby a domain of objects or events, defining the operations of description and explanation. Thus, it concerns the goals or substantive objectives of geographical studies. Hence, a geographer is concerned with the universe of finely interacting complex systems of Earth's environment, biotic, abiotic, physical, human, social, cultural, economic, political, interregional, intra-regional, degradation, conservation, and deterministic, possibilistic, thereby making the discipline a purely multidimensional, interdisciplinary, transdisciplinary, and multidisciplinary one. And the geographer is both a spatial scientist as well as a spatial scientist with an immense potential role to play in the physico-human development of a region. One of my most admired professor, Dr. Harvey, David Harvey. Geographers normally organize their thoughts around the following 5 major themes, each one of which, in its own way, defines the nature of geography. One is areal differentiation theme, you know very well, landscape theme, man-environment theme, then spatial distribution theme, and finally the geometric theme. The scope and content of modern geography is viewed as a geocube. The cube, each one of its 6 planes, represents the perspective of a geographer. Plane number 1, it concerns global issues, species extinction, deforestation, ozone hole, climate change, weather forecasting, population growth and distribution, aging population, tourism, and war. Plane 2, physical earth, earthquake, tsunami, volcano, storms, hurricane, floods, drought, forest fire, conflicts in earth systems. Human society, economy, and development concerns ethnicity and religion, language, literacy, health, migration, mobility, poverty, economic development, pollution in urban systems. Number 4, human exploitation of earth, nature, minerals, water resources, land resources, energy resources, agriculture, food resources and distribution, housing, waste and pollution. On the fifth plane lies the man's activity space that measures, monitors, maps, and models the phenomena. Risk, transport, planning, education, GIS, geographic skills, using maps, facilities management, and resource management. And the sixth plane comprises the regional complexities: mountains, deserts, wetlands, rivers, oceans and seas, urban landscapes, rural landscape, karst landscapes, polar regions. Therefore, number of planes a cube has is 6. Number of parameters in each plane is 9. And the total number of parameters of geographers concerned, 6 9s is 54. Just imagine, we as geographer, we do not think beyond these 54 parameters. We do not research nothing beyond these 54 parameters. So geography is a science of place and space, where things are located on the surface of the earth, why they are located, where they are, how places differ from one another, and how people interact with the environment. It is unique in linking the social sciences and natural sciences together. It takes us to different land and people with different cultures. To solve the location problem, all required is to overlay and judge sets of spatial information in a form we know and call it map. And the art, science, and technology of mapping comprises the discipline of cartography. And geographic literacy is absolutely a delicate function of cartographic literacy. And hence, geography is unique. To comprehend the core of geography, we need a real-time, well-designed depiction of our habitat, economy, and society, along with their interrelationships, that is, maps. Cartographic processes involve depiction of the Earth's surface, convenient reduction through scale factor, mathematical principles of transformation of 3D surface onto 2D plane, orientation through relatively fixed reference directions, and surveying for building the ground control network. That is the reference map or the base map we use. Number 2, generating the elevation database. That is the topographical map, topographic database. And number 3, geographical overlays through thematic data layers. That is the thematic maps. All these require an understanding of several distinctively separate disciplines. GCN, map projection with innumerable probabilities and combinations of multiple deformations, require a knowledge base of algebra, coordinate geometry, 2D, 3D trigonometry, geodesy, field astronomy, remote sensing GIS, photogrammetry, and cartography. T-base requires the knowledge of ground surveying and leveling, including traversing, triangulation, and contouring with instruments like chain, compass, plane table, theodolite, total station, GPS, remote sensing. And graphic overlays, the 7 fundamental principles of rays are essentially maintained while mapping our Earth's surface, either a part or whole of it. Number 1, maps are drawn on a predetermined scale. Number 2, maps are related to a system of parallels and meridians. Number 3, maps are selective. Number 4, maps emphasize certain of the selective features. Number 5, maps are symbolized. Number 6, maps are generalized. And number 7, maps are lettered, titled, and labeled. Today, mapping refers to all the processes involved in making a map: collecting data, performing the map's design, finishing the map for distribution in a hard copy or the web. Thus, it is the process of designing, compiling, and producing maps. The map maker is called a cartographer, and the INCA, International Cartographic Association, it defines cartography lately as the art, science, and technology of making maps together with the study as scientific documents and works of art, including all types of maps, plans, charts, and sections, three-dimensional models and globes representing the art or any celestial body at any scale. This cartography originated during the Greek civilization and evolved through four phases. Number one, the archaic or the classical period up to 4th century BC, then Hellenistic period, 4th to 3rd century BC, then Greco-Roman period, 2nd to century BC to 2nd century AD, and the age of Ptolemy, 2nd century AD. Anaximander conceptualized a circular and flat earth, 6th century BC. Pythagoras, Herodotus, and Democritus developed and contributed new theories and applications in the 6th to 4th century BC. Since then, developed the discipline of geodesy, map projection, and cartography. The quest is still on, even now, for a flawless 2D representation of 3D Earth surface. I will show you in the form of some slides some of the pioneering works of the ancient cartographers. This is the oldest map available. It depicts a town plan with erupting volcano on the background. Okay? This is the ancient Babylonians. They had a relatively advanced culture, and this kind of map has been reproduced from this kind of clay tablet in depicting the Gasur, city of Gasur. This is the town plan of the Nippur that was also on a clay tablet. This is also on a clay tablet. This is the Babylonian world map. Right there. See what is written. These are all rivers, and all the countries or continents surround the city of Babylon in the center. And islands, these are the star triangles. So Egyptians were advanced for their time. Even they made maps on the coffin. Leads from 2000 BCE illustrate both water and land routes to the underworld. And survey maps were also perhaps the most common Egyptian maps. They surveyed and made the first topographic map, Turin Papyrus, and they collected revenue based on these survey maps during that period. This is the Achilles shield, and this shield is circular. See, this is river and ocean on the margin, then cattle, then plowing, then city of peace, then earth, sea, sun, moon, stars. They are lies at the center of the map. This is the Anaximander's world map. 3 different continents, Europe, Libya, and Asia. Libya means Libya is today's Africa. This is Hecatu's world map, part of the circuit of the earth. And this is Dicariacus world map in 3rd century BCE. And this is the Eratosthenes world map drawn in 220 BCE. This is not, the size is not like a A4 size map. It is several feet long and several feet wide. In most common case, 22 feet by 10 feet or 15 feet. This is the orb of Crete, drawn in 150 BCE and based on Homer's Ulysses. This is a 10 feet wide globe. This globe with a diameter of 10 feet. And Strabo wrote 17 volumes of geography. They are still intact. And this kind of map has been drawn by Strabo at that time. This is Tabula Rogerina, and it is drawn by Al-Adrasi. He was invited by Norman King Roger II and asked to produce a book on cartography. And the result was this Tabula Rogeriana. And most important thing is that it is oriented with south at the top. This is Putinger map. It is drawn during the days when all roads lead to Rome. The so-called Putinger map served as a handy guide to the empire's transportation network. This map is 22 feet long and just 1 foot wide. And it shows about 60,000 miles of Roman roads stretching from Western Europe to the Middle East. An additional section also shows India, Sri Lanka, and other parts of Asia. Then comes the reign of Ptolemy. This is Ptolemy's world map. It is based on a projection. It is derived from longitude-latitude tables. No more encircling ocean. Caspian Sea enclosed. Most complete geography. Enclosed Indian Ocean. See, this is the conic projection he first developed. And this is the pseudo-conic projection. All the meridians here are smooth curves. This is developed by Ptolemy and is known as Ptolemy's projection. And these are the regional maps produced by Ptolemy or drawn by Ptolemy in 150 C Central. This is the stone map of China. Engraved stone maps, they were transferred to paper by ink rubbing. This is one of the earliest surviving world maps from the Far East. China's Daming, the amalgamated map of Ming Empire. It is drawn on silk as early as in 1389. It spans the entire Eurasian continent from Japan to the Atlantic Ocean. And with obviously hugely distorted size. This is Japan, this is Korea, this is the China at the center, this is India, and this is Africa. And this is the first map to show Africa with a southern tip. That means the continent could be circumnavigated. This is the silk map of China, used to demonstrate the new Confucian dynasty's cosmic legitimacy. It spans from Korea to Europe. This is the paper map. Wangho River, Yellow River, and the Great Wall is shown here. This is the Japanese maps, folded maps, clouds used to compress distance to time. There are clouds, several clouds drawn on this map. And this is Tio Mapamundi. It looks like a T. Above the T lies Asia, in one part Europe and another part Africa, surrounded by Mare or the ocean. This Asian part is also known as Orients or the Oriental region, and this is Occidental region. In 1300, Mapamundi is another thing. The illustration is obviously circular, with Jerusalem placed at the center of the map, the Garden of Eden in a ring of fire near the top of the map. Near the top of the map. And the whole thing oriented with east at the top. Another peculiarity of this Mapamundi, east at the top, north on the left. In 1400, Fra Mauro, a monk, he created this map. It considered as one of the finest pieces of medieval cartography. It's a large round map, around 2 meters in diameter, painted on vellum and traced in a wooden frame. It depicts the known world at that time, that is Europe, Asia, and Africa. And it is oriented with south at the top, like developed by Al-Adrisi. And then came the Portolan charts. These are the creations. The survey first came with plane tables or the compass. These are the lines of bearings. Intersection surveys Other edition surveys are taken and mapped. These are known as portal and chart of 1500. And then came Mercator. Gerardus Mercator map. It is notable for being the first attempt to make a round earth look right on the flat surface. What do you mean by right? That is, the scale remains same both latitudinally and longitudinally, so that shape remains undistorted. And Mercator sought to account for this by keeping the line straight and distorting the size of the objects closest to the pole. Right? And the line that allows to measure or find constant bearings, they are known as loxodromes. Later it is called rhumb lines. And this is the Renaissance map. After 1000 years, Ptolemy is rediscovered in Europe, and revisions accompanied translations. And those things actually helped us to trace the history or the location of the total cartographic base about our known world. This is Cantino Planisphere, notoriously for closely guarding the location of new lands found by its explorers. Heavily guarded by the Kingdom of Portugal. This Portuguese and the Spanish people, they were really good cartographers, and they kept it secret. He succeeded in his mission, and the map that he smuggled out of Portugal has since become famous. Not only does it depict Africa, India, and Europe in unprecedented detail, it stands as one of the earliest known maps to show the coastline of Portugal's New World territories in South America. This is the first colony of the Portugal, and to the north of Brazil. The map also includes a small grouping of landmasses that appear to be Hispaniola, Cuba, and part of the American East Coast. This is Rosselli's world map, the first whole world map. And this is the first map that depicts Antarctica. It is in 1820. This is Appian's world map, heart-shaped. Okay, and a modification of the Ptolemy's projection, Bone's projection. This is Walsey Muller's world map. This is the first map that shows North America and South America. This name is written there, and US Library of Congress in 2003 purchased it with the highest price ever, $10 million. And this is the birth certificate of the United States. Ortelius world map from the first modern atlas, Theatrum Orbis Terrarum, that is theater of the world. In 1600, Ricci map. It was composed by Jesuit priest Ricci, oldest surviving map in Chinese to show the Americas. The map shows China at the center, America on the right, Europe and Africa and Asia, they are on the west. This is a Danish map, large scale map for every region. And they published 11 volumes and is known as Atlas Major, and is drawn by not less than 100 people or cartographers. This is Hondius world map in 1630. It is a Renaissance map, and Hondius improved and reissued Mercator's atlas. This is the Great Circle route, this curve. Van Quillen's world map, it is based on Mercator's projection, and portal and lines are finally correct, so that you can see the shape of the continents. They are more accurate than ever. And then the Great Triangulation Survey undertaken by British in Southeast Asia, particularly India, built from a single baseline, and George Everest just finished this central spine of survey during his lifetime. And then came the revolution in mapping called thematic map revolution for the next 300 years, and again still now it's going on. This is the first weather map produced by Halley's wind map in 1686. This is Halley's declination map, means magnetic declination map, the degree of declination, magnetic declination, different places of the world. This is the first geological map drawn by Smith for British Isles, and he is popularly known as William Strata Smith. And the strata developed based on the principles of faunal succession. And this is the first flow map drawn by Harness. It shows transportation magnitudes in terms of the width of the transport lines, proportionally scaled lines, as we do today. This is the first population density map in terms of dot map, show the concentration of populations of France, drawn in 1830. This is a Snow's cholera map. It shows the associated frequency of the cholera affected people and the location of the palms. It is considered as the origin of the spatial analysis. That is why cholera breakout occurs at that particular points only. This is D'Angeville's population map, the first choroplate map showing population density of France. This is Peterman's cholera map, Hatchery, or simply by color density is shown, concentration is shown by the intensity of colors. This is Pritchard's ethnographic map, the first chorochromatic map, or the place color map, or the color patch map. This is the first ideal geological cross-section drawn in 1838 by William Strata Smith. And it is a detailed one showing the distribution of fauna and flora across that line. This is the emigration, Miniard's emigration flow map, 1862. It shows 4 attributes: magnitude of migration, location of migration, direction of migration, with nationalities of the racial groups. Very detailed. And these were the instruments that are used to draw these maps. These were the instruments. Now, I will talk of only the philosophies of 2 distinguished and 2 of my favorite contemporary geographers of the world. One is Waldo Rudolph Tobler. The first one, his demise was in 2008, February 2008, close to the death of our professor, Betal. Betal probably also passed away in 2018. He was an American Swiss geographer and cartographer. He pioneered the use of computers in cartography. In his 1959 paper, Automation and Cartography, he formulated 2 universal laws of geography. The first one is known as Tobler's first law, or TFL. What is that? Everything is related to everything else, but near things are more related than distant things. This is the first law. And the second law he gave in 1999. The phenomenon external to an area of interest affects what goes on inside. That means all that is happening in our surroundings or about our surroundings, we are influenced. These all actions are influenced by factors somewhere else, located somewhere else, or external factors. These 2 are really, really applicable in these days. But nobody cared. People are egoistic and nobody cared. Until the advent of the GIS, these two laws were never taught in any academic institutions or the Department of Geography. And the TFL and the TSL, they are gaining popularity in the contemporary world. He invented a method of smooth 2D mass preserving aerial data redistribution. He built a global latitude longitude oriented demographic information base with second order resolution, better than was previously available. He also examined the development of smooth fine element and categorical pycnophylactic geographic information reallocation model. In July 1999, he presented a keynote speech, "The World is Shriveling as It Shrinks," at the ESRI International Users Conference, and was the recipient of Lifetime Achievement Award in GIS by ESRI. His keen interest in computational geography results in the analysis of graphical vector fields and the development of migration and global trade wind models. In 2003, he released FlowMapper, a free software that ESRI ArcGIS incorporated in 2005. In 1973, he invented the hyperelliptical projection, now known as the Tobler's hyperelliptical projection, belonging to the equal area pseudo-cylindrical group. In its normal aspect, parallels of latitudes are parallel straight lines. Their spacing is computed to preserve the equal area property. The projection blends the cylindrical equal area projection with meridians of longitude that follows a particular kind of curve known as superellipses or Lemay curve, or sometimes as hyperellipses. The curve is described as alpha to the power k plus beta to the power k equal to gamma to the power k. The relative weight of the cylindrical equal area projection is given as alpha, ranging from all cylindrical equal area with alpha equal to 1 and all hyperellipses with alpha equal to 0. When alpha is 0 and k equal to 1, the projection becomes a collignon projection, that on the right side of it. And when alpha is 0 and k equal to 2, gamma equal to 1.2731, the projection becomes a moloid projection. And when alpha is 0, k equal to 2.5, and gamma equal to 1.136, the projection becomes Tobler's hyperelliptical projection. Another man I most admire is Trevor Paglen. He was born in 1974 and is doing great. Very few of us know about him. He is the pioneer, he is the inventor of the approach of experimental geography. He belongs to a new breed of researcher at the University of California, Berkeley. He takes a wildly experimental approach to studying the strategic and practical boundaries of contested public or private space on Earth. He is known for investigating the invisible through the visible with a wide-reaching approach that spans image making, sculpture, investigative journalism, writing, engineering, and numerous other disciplines. The clandestine and the hidden are explored through abstraction, romanticism, and technology. His investigation onto the epistemology of representation can be seen in his symbiology and codenames to explore questions surrounding military culture and language. Among his chief concerns are learning how to see the historical moment we live in and developing the means to imagine alternative futures. He is the only living geographer about whom a movie has been prepared and shown in International Film Festival in April 2021. The name of the film is The Unseen Skies. It is a documentary film written and directed by Yara Bau on the works of Trevor Paglen as he undertakes one of his most ambitious projects, Orbital Reflector, launching an artwork into space to highlight the global impact of technology in the 21st century. An American artist travels through the Nevada desert to launch a satellite into orbit to show that the skies are more than exclusive playground of the military industrial complex. The film had its premiere at the San Francisco International Film Festival in April 2021. But sorry to say that the Trump government did not withdraw the fund for the completion of the project. Paglin's work has been profiled in the New York Times, the New Yorker, the Wall Street Journal, Wired, the Financial Times, Art Forum, and Aperture. In 2014, he received the Electronic Frontier Foundation's Pioneer Award, and 2016, he won the Deutsche Börse Photography Prize, and Paglin was named a MacArthur Fellow in 2017 only. His major publications include Torture Taxi on the Trail of CIA's rendition flights in 2006. Next book, I could tell you, but then you would have to be destroyed by me. In 2007, Cabinet 14, Shadows in 2007, an Atlas of Radical Cartography in 2008, Blank Spots on the Map, the Dark Geography of the Pentagon's Secret World in 2009, Experimental Geography, Radical Approaches to Landscape Cartography and Urbanism in 2009, Invisible, Covert Operations and Classified Landscapes in 2010, The Last Pictures in 2012, Autonomy Cube in 2016, From the Achievers of Peter Merlin 2019, and Adversarially Revolved Hallucinations in 2024. Can you imagine? Can you understand anything about what is the nature of the book? What is should be written there? The names are this. He is a highly intellectual person I have ever seen in geography. In his own words, when most people think about geography, they link about maps. Lots of maps. Maps with state capitals and national territories, maps showing mountains and rivers, forests and lakes, maps showing population distributions and migration patterns, and indeed, that is not a wholly inaccurate idea of what the field is all about. Modern geography and mapmaking were indeed once inseparable. Renaissance geographers like Martilius Germanus and Pedro Renal, having rediscovered Greek texts on geography, most importantly Ptolemy's geography, put the ancient world of knowledge to work in the service of Spanish and Portuguese empires. Martilius's maps from the late 15th century updated the old Greek cartographic projections to include the Marco Polo's exploration of the East as well as Portuguese forays along the African coast. Renal's Portolan maps are some of the oldest modern nautical charts. Cartography, it turned out, was an indispensable tool for imperial expansion. If new territories were to be controlled, they had to be mapped. And that is why cartography is important and became important to kings and queens or the rulers. Within a few decades, royal cartographers filled in blank spots on old maps. In 1500, Juan de la Cosa, who accompanied Columbus on 3 voyages as captains of Santa Maria, produced the Mappa Mundi, the first known map to depict the New World. Geography was such an important instrument of Portuguese and Spanish colonialism that early modern maps were some of these empires' greatest secrets. Anyone caught leaking a map to foreign power could be punished by death. In our own time, another cartographic renaissance is taking place. In popular cultures, free software applications like Google Earth and MapQuest have become almost indispensable parts of our everyday life. We use online mapping applications to get directions to unfamiliar addresses and to virtually explore the globe with the aid of publicly available satellite imagery. Consumer available global positioning systems have made latitude and longitude coordinates a part of the cultural vernacular. In the arts, legions of cultural producers have been exercising the power to map. Gallery and museum exhibitions are dedicated to every variety of creative cartography. locative media has emerged as a form of techno-site specificity. In the antiquities market, old maps have come to command historically unprecedented prices at auction. Academia, too, has been seized by the new powers of mapmaking. Geographical information systems have become a new lingua franca for collecting, collating, and representing data in the fields as diverse as archaeology, biology, climatology, demography, epidemiology, and zoology. But does the proliferation of mapping technologies and practices really point to a new geographic cultural a priori? Not necessarily. Although geography and cartography have commonly intellectual and practical ancestors and are often located within the same departments at universities, they can suggest very different ways of seeing and understanding the world. Contemporary geography has little more than a cursory relationship to all varieties of cartography. Most critical geographers have a healthy skepticism for the God's eye vantage points implicit in much cartographic practice. As useful as maps can be, they can only provide very rough guides to what constitutes a particular space. Geography, thus, is a curiously and powerfully transdisciplinary discipline. In any given geography department, one is likely to find people studying everything from the Big Bang to the plate tectonics, to glacial lake outbursts, to supercyclone devastating Sundarban, ethnic violence in Mizoram, to plantation farming in Darjeeling Hill region, ecofeminism, sustainable development, and what not. In the post-war US, university officials routinely equated the discipline's lack of systemic, methodological, and discursive norms with a lack of seriousness and rigor, a perception that led to the numerous departments being closed for lack of institutional support. This happened to all the universities of Ivy League at that time. The end of geography at Harvard was typical of what happened in the field. Officials shut down its geography department in 1948, mind that, after being flummoxed by their inability to extract a clear definition of the subject, to grasp the substance of geography, or to determine its boundaries with other disciplines. The academic brass saw the field as hopelessly amorphous. But believe me, this hopeless amorphousness is, in fact, geography's greatest strength. Geography's major theoretical underpinnings come from two related ideas. One is materialism and another is the production of space. Materialism is the simple idea that the world is made out of stuff or objects, and all phenomena arise out of the interactions of material in the world. In the Western tradition, the philosophical materialism goes back to Democritus, Anaxagoras, and Epicurus, whose conceptions of reality differed sharply from the Plato's metaphysics. Later philosophers like Thomas Hobbes, David Hume, Ludwig Feuerbach, and Karl Marx developed materialist philosophies in contradistinction to Cartesian dualism and German idealism. Methodologically, materialism suggests an empirical, although not necessarily positivistic approach to understanding the world. In the contemporary intellectual climate, a materialist approach takes relationality for granted, but an analytic approach that insists of stuff can be a powerful way of circumventing and tempering the quasi-solipsistic tendencies found in some strains of vulgar post-structuralism. Geography's second overreaching axiom has to do with what we generally call the production of space, after Henry Lefebvre. It says that humans create the world around them, and humans are in turn created by the world around them. In other words, the human condition is characterized by a feedback loop between human activity and our material surroundings. Thus, space is not a container for human activities. to take place within, but is actively produced through human activity. The spaces humans produce, in turn, set powerful constraints upon subsequent activity. When I write an essay such as this, get it published in a book, and put it on the shelf in a bookstore or museum, I am participating in the production of space. The same holds true for geography. When I study geography, write about geography, teach geography, go to geography conferences, and take part in a geography department, I am helping to produce a space called geography. None of these examples is a metaphor of a space of culture. Isn't just a structure of feeling, but an infrastructure of feeling. Geography is not just a method of inquiry, but necessarily entails the production of a space of inquiry. Geographers might study the production of space, but through that study, they are also producing space. Put simply, geographers do not just study geography, they create geographies. The same is true for any other field and in any other form of practice. Taking this head on, incorporating it into one's practice is what Paglin meant by experimental geography. Although the tellers of geographical story have changed, the various aims of the subject remains the same: to explore the world we know in the past, present, and future. Today, environment, which deal with a new idea of electronic environments and spaces. Since the 1970s, a transverse shift of approach slowly began to make inroads from how man lives where he lives to why man lives where he lives. Since the 1980s, debate and discussion mainly focused on pollution, degradation, ozone depletion, oil spills, acid rain, deforestation, and population explosion. Since the 1990s, natural hazards, natural disasters, El Nino, ENSO, climate change, GIS, RS, GPS, sustainable development, ICT, IoT, ISC, analysis became the keywords, buzzwords rather. Computer technology grew fast. Hordes of software from corporate houses and labs are coming into the market almost every day. At the dawn of the new millennium, scientific disciplines are esteemed, supported, and patronized largely to the degree to which they are perceived as providing a return on invested societal resources. A healthier role for the discipline is for geographers to seek ways of asserting intellectual leadership and shaping social agenda along more human and social just lines. The new fields of research collapsing space and time, electronic frontier, global village, digital determinism and the trap of endless description, diversity, fragmented reality and nonlinear reasoning, hyper reality, hyper modern world of reality, information society, information superhighway, network geography, postmodern, critical and deep geography, shrinking world, surfing the surfaces, and virtual land of expression. In the contemporary world, the idea of global village becomes a reality. The economic decision is now liberated from location. Human life is liberated from the constraints of space and the frictional effects of distance. Anything is now possible anywhere at any time. All information is accessible everywhere and anywhere. Another area of geographical interest relates to the idea of surveillance, political regulation, civic influence, and their future developments. The classic idea of Big Brother is watching you is connected with the convergence of the mobile phones, computer, and GPS. The technology of ranging location, the paths of a person's movement can be easily traced and developing so quickly that personal privacy might be in jeopardy. It concerns a big issue of free speech, civic influence, and democracy in the networks. Analysis of networks and their social, cultural, economic, and political impacts have led to the notion of space of flow and space of places. Cartography nowadays is experiencing a kind of renaissance. marked by the emergence of a complex and creative network of mappings and the ways of interpreting them, ways of visualizing them. In contemporary cartographic epistemologies, a diverse range of mapping is seen to emerge from a shifting creative milieu, the result of which is not a unidirectional evolutionary tree of maps, but rather a complex branching with rhizomatic structure. Geography beautifully entwines the internal philosophies of both the physical and the social sciences to unravel the human drama, the social fabric, the dynamics of human life and civilization on Earth, to enrich the universe of knowledge. The role of cartography in geography, teaching, and how maps spatially educate us in contemporary issues was never before so exciting and important. Thus, cartographic literacy is a must to understand the fabric of modern world in terms of human habitat, economy, and society. But notes of warning are there. The importance of technology is measured directly through the analytical capacity and provides the power to handle the massive amount of data.
हैं?
The dynamics of real-time data
आपको ढूंढने
update.
गए आप नहीं थे? नहीं, हमने डीसी ऑफिस में गया, डीसी ऑफिस थोड़ा काम के लिए अभी आए।
The dynamics of real-time data updates with a large number of variables create the instrumental utility that information technology has. However, the important factor is the interpretation of a phenomenon, not the measurement of it. Number two, ArcGIS, SAS, SPSS, and ADAS provide efficiency and a new computerized way of describing the environment, but the real understanding comes from the researcher with the wisdom of core geography, from the perspective of deep understanding, critical approach. And number three, the danger of appreciating and relying too much on GIS leads to the trap of endless description. As Souza emphasized, the impacts of GIS in the hypermodern world of generalized information and communication reassert a critical understanding of the socio-spatial dialectic. My dear audience, I'm happy that you have invited me and proud that you have chosen to participate. Thank you all belonging to the CPBU, especially the Department of Geography. And this you must know, you should know, or I believe you know, this is the peace symbol of United Nations. Do you know what projection they have used here? This is azimuthal equidistant projection. And one more thing, if you allow me, I would like to draw your attention. Being the editor in chief of the peer reviewed journal that assigns DOI to each article, I do appeal to the researcher fraternity to subscribe and submit at least one of your valued research in the IJSS whenever convenience occurs. Our website is now open to all. Thank you, organizers. And thank you again, everyone here, for being brave to tolerate me for such a long time. It's already 12:30, I think, or 12:20. Thank you. Exactly, exactly.
Ah,
দীপক বোধহয় নেই, রঞ্জন আছে।
Hello. Ah, first of all, my একটু ডিস্টার্ব হচ্ছে। Thank you, sir.
থ্যাংক ইউ,
Sir,
থ্যাংক ইউ।
actually, I was traveling for my department, so I joined after 15 minutes from the scheduled time. So, anyway, so I have listened and really I am grateful that Najrul today has arranged this type of program, and so we are really grateful to sir because Professor H.R. BETAL Memorial Lecture what he has arranged, and you have actually given a lot of uh, new also ideas that were unknown to all of us. So I think the information what Professor Ashis Sarkar sir today has delivered in Professor H.R. BETAL Memorial Lecture, it will give uh, many new information to the participants, to the research scholars today who have joined this program. And Professor H.R. BETAL, although I did not actually belong actually the Calcutta University, but Professor BETAL, he was very close to us in many occasions for Bhaiba Boshi, for refresher course, orientation program when it was actually organized in many of the occasions. Professor H.R. BETAL, who also acted as research assistant, and in as research assistant, he delivered many of the basic cartographic issues. And I am really proud that at least in two research, refresher course program, I could have actually attended where Professor BETAL actually uh, delivered his lecture as a resource person. So, Professor BETAL, who basically in the field of cartography and as a follower of Professor BETAL, we really think that cartography as nowadays in the university level, even if we see in our West Bengal, in many of the university departments, the cartography as a special paper, to some extent, it has been actually the number of departments where cartography is not actually taught right now. Only so far my knowledge is concerned right now in the Department of Geography, Applied Geography, University of North Bengal, and right now also in Cooch Panchanan, Barma University. So this cartography as a subject is now being taught. So I hope the whatever the today's daily lectures Professor Ashis Kumar sir has given, it will give really a new information and new thoughts, or mostly to the scholars and the students. We are really have little bit of knowledge and we don't know about much more. So today's lecture is really a fruitful one in one sense that Professor Ashis Kumar Sarkar sir has given a right thought-provoking address in the memorial lecture of Professor H.R. Betal. So thank you, sir, and thank you, organizers, and especially thanks to Dr. Nazrul Islam, who also actually arranged this such a beautiful program today. Thank you.
Thank you.
Mm. Mm. হ্যাঁ শোনা যাচ্ছে বলুন
এক্সাম সেন্টারে জামার চলছে তো ঠিকঠাক শোনা যাচ্ছে না কোনো রকমের লেকচারটা শুনেছি
পার্থ হাত তুলেছে, পার্থ কিছু বলবে।
Partho, please. But he's muted. At first, you unmute your microphone.
ভেরি গুড আফটারনুন স্যার। অনেকদিন বাদে আপনার ক্লাস আমি অ্যাটেন্ড করছি, আর আমি লাকি যে আমি বেতাল স্যারের ক্লাসও অ্যাটেন্ড করেছি। তো আর কার্টোগ্রাফি আমার স্পেশাল পেপার ছিল, তো আমার খুব ভালো লাগছে আজকে, যেন আমি কলেজ ডেজে ফিরে গেছি, আমার এরকমটা মনে হচ্ছে। তো স্যার, অ্যাজ এ স্কলার অ্যান্ড অফ দিস জিওগ্রাফি ডিপার্টমেন্ট ফ্রম কোচবিহার পঞ্চানন বর্মা ইউনিভার্সিটি অ্যান্ড অ্যাজ আ প্রফেসর, অ্যাসিস্ট্যান্ট প্রফেসর ফ্রম দ্য ইউনিভার্সিটি, আই থ্যাংক ইউ ফর দিস নাইস ডেলিভারেশন স্যার। অনেকদিন বাদে খুব ভালো লাগলো, আর অনেকদিন বাদে কার্টোগ্রাফি নিয়ে লেকচার শুনছি। এটা মানে এখন খুব কমে গেছে, মানে কার্টোগ্রাফার মানে মানে লেকচার খুব কম হয় এখন, শুধুমাত্র মানে বেসিক কার্টোগ্রাফি নিয়ে বা জিওগ্রাফি নিয়ে তো এটা থট প্রভোকিং লেকচার খুব কম পাই আমরা। তো থ্যাংকস আ লট স্যার। আর অনেকদিন বাদে আমি স্টুডেন্ট লাইফে ফিরে যেতে পেরেছি, আমি ক্লাসরুমেই বসে আছি এখন, বাট আমার মনে হচ্ছে আমি আজকে মানে উল্টো দিকে বসে আছি এবার অনেকদিন বাদে। তো থ্যাংক ইউ স্যার, থ্যাংকস আ লট। আর ডিপার্টমেন্টকে অনেক ধন্যবাদ এই প্রোগ্রামটা অ্যারেঞ্জ করার জন্য, অনেকদিন বাদে খুব ভালো লাগলো।
আমি ডিপার্টমেন্টকে আমিও রিকোয়েস্ট করেছি দুটো জিনিস, এই অ্যানুয়াল লেকচারটা যেন চলতে থাকে কন্টিনিউ সারা দেশে। আমাদের কিন্তু অভাব নেই, পুরনো এখনো পর্যন্ত অনেক পুরনো কার্টোগ্রাফার আছে আমাদের দেশে। আর দ্বিতীয় জিনিস হচ্ছে, যদি একটা অ্যাওয়ার্ড চালু করা যায় তাহলে কিন্তু সার্টিফিকেটের ফর্মে, ছাপাতে খুব একটা পয়সাও লাগবে না, কিন্তু স্টুডেন্টরা অনেক মোটিভেটেড হবে।
একদম এটা ঠিক স্যার, ঠিক বলেছেন।
প্রপোজাল স্যার, আমরা এটা মাথায় রাখবো ইন ফিউচার, আর কি আমরা এরকম প্রোগ্রাম আরো আমরা চেষ্টা করব ইন ফিউচার রিয়েলি।
স্যার শোনা যাচ্ছে? হ্যাঁ স্যার, অ্যাকচুয়ালি আমার একবার সৌভাগ্য হয়েছিল স্যারকে দেখার, কারণ তখন পড়তাম, তখন মাঝে মাঝে আমাদের সিইউতে ডিপার্টমেন্টে কিছু প্রোগ্রাম হলে স্যার, তারপর ওই বা পুরানো যারা টিচার ছিলেন উনি মনতত্ত্ব ওরা আসতেন, তো তখন দেখেছি উনাকে বা পুরোনো টিচারদের একসঙ্গে দেখেছি, খুব ভালো লাগতো। আজ দেখেছি স্যার আমাদের ওখানে একটা রুম আছে, ওখানে এখনো সেই স্যারের যে লাস্ট ক্লাস সম্ভবত তার ছবিটা তুলে রাখা আছে, সেটা আমি আবার ছবি তুলে নিয়ে এসেছিলাম। মানে এত সুন্দর মনে হচ্ছে যেন ওটা কোনো একটা টেক্সট বুকে যেমন ছবি থাকে না, পুরো সেভাবেই লেখা আছে। মানে এত সুন্দর হাতের লেখা বা এত সুন্দর ড্রয়িং কল্পনায় জাস্ট করা যায় না। আর আর সবচেয়ে যেটা ব্যাপার হচ্ছে যে মানে আমাদের ক্যালকাটা ইউনিভার্সিটির একটা এত বড় কার্টোগ্রাফিক লিগাসি ছিল, কিন্তু ক্যালকাটা না, আমরা ওয়েস্ট বেঙ্গলের আর কি, তখন বলছি যে বেতাল বাবু বা সেই সময় যারা ছিলেন, কিন্তু দিনের পর দিন দেখা যাচ্ছে যে স্পেশাল পেপারটাই উঠে যাচ্ছে কার্টোগ্রাফি। এটা একটা খুব দুঃখের বিষয় আর কি আজকের দিনের জন্য। এটা একটা খুবই দুঃখের, যদি সেরকম চালু হয় বা ইউনিভার্সিটিগুলোতে কার্টোগ্রাফি স্পেশাল পেপার আবার পড়ানো হয়, তাহলে মনে হচ্ছে যে খুবই ভালো হবে, যে মানে সবাই শিখতে পারবে। এখন তো রিমোট
আসলে কি বিমান, আমাদের সময় আমরা আন্ডার গ্রাজুয়েটেও স্পেশাল পেপার পড়তাম। আন্ডার গ্রাজুয়েটে কার্টোগ্রাফি স্পেশাল, দুটো স্পেশাল পেপার নিতে হতো। আমরা পড়েছিলাম, আমার ছিল কার্টোগ্রাফি আর ইন্ডাস্ট্রিয়াল জিওগ্রাফি। তারপরে এমনিতে গিয়েও একটা স্পেশাল পেপার কার্টোগ্রাফি। ফলে ছেলেমেয়েরা গোড়া থেকেই ট্রেন্ড হতো, ভালো লাগতো সাবজেক্টটা। পরে আন্ডার গ্রাজুয়েটে তুলে দেওয়া হলো, আর কার্টোগ্রাফির লোকজনকে অ্যাপয়েন্ট করা হয়নি কলকাতা ইউনিভার্সিটিতে। ফলে যারা ছিলেন রিটায়ার করে যাওয়ার পর আর তো কেউ পড়ানোর নেই, কিছু করার নেই।
হ্যাঁ, মানে একদমই স্যার। মানে ধরুন এখন যে ইনস্টিটিউশনে আমি আছি ন্যাটমো, এখানে এসে বিশাল উপলব্ধি করি যে কার্টোগ্রাফিটা কতটা দরকার স্যার আমাদের জন্য। অ্যাকচুয়ালি স্যার জিওগ্রাফারদের আইডেন্টিটিও স্যার একটা ম্যাপ, সেটা যদি না ভালো করে শেখানো হয় তাহলে স্যার আমরা কোথায় যাবো, আমরা কোথায় যাবো?
তুমি তো এখন
খুবই দরকার
বসে বুঝতে পারছো ডিজাইনিং কাকে বলে, লেআউট কাকে বলে, লেটারিং কাকে বলে।
হ্যাঁ একদম স্যার, এটা যদি আরো আগে শিখে আসতে পারতাম তাহলে অসুবিধা হতো না। থ্যাংক ইউ স্যার এত সুন্দর একটা লেকচারের জন্য, আপনাকে অনেক ধন্যবাদ স্যার। থ্যাংক ইউ স্যার, থ্যাংক ইউ স্যার।
একদম একদম একদম।
Thank you, Nozulda. Sir, good afternoon, sir.
Hi, good afternoon. Good afternoon.
Good afternoon, Ranjanda.
Good afternoon.
Okay. A very good afternoon to all of you. It has been such an honor to be a part of this wonderful event. On behalf of the Department of Geography, Behar Panchanan Barma University, I convey my sincere thanks to our Honorable Vice Chancellor for giving his consent to conduct this kind of lecture. So we are very much thankful. I'd like to extend my heartfelt thanks and gratitude to our esteemed speaker, our respected Professor, Sir Professor Ashis Sarkar, former head of the Department of Geography, Presidency College, for his nice and lucid lecture. Definitely, we are very much enriched today. We are very much thankful to you, sir. My sincere thanks to Professor D.K. Mondol, head of the Department, University of North Bengal, Department of Geography, and our renowned another professor, Professor Ranjan is also present here. Really, we are very much thankful to them. And all other our esteemed colleagues from various institutions, colleges, and research institutions. I think Amrita is my friend also, she is present here, Dr. Amrita Pramanik, and any other colleagues who have come from here, various institutions. So really we are very much thankful to them. Actually, they have enriched to us for their nice presence here. We also thankful a wide round of applause and thanks to all the participants, our research scholars, students who made the event a memorable one. Finally, I taking the time to be with us today and helping us and all. Thank you once again to everyone for today's program. Really, we are very much thankful to our respected Professor Ashis Sarkar. Once again, said thank you for your presence here. Thank you.
Thank you, sir.
Thank you. Thank you. Okay, thank you. তাহলে লিভ
Thank
করছি
you,
Thank you,
sir.
sir.
ভালো লাগলো স্যার, খুব ভালো লাগলো, অনেকদিন
হ্যাঁ,
বাদে আর কি। খুব ভালো লাগলো,
অনেকদিন
আবার
বাদে।
দেখা হবে, আমরা আবার মিট করবো। আর এবার
হ্যাঁ,
কিন্তু
ওটা
স্যার কোনো
ওটা তো
ব্ল্যাঙ্কেট মনে নয়।
যেতে পারিনি, তবে যাবো
No,
এই
no, so
বছর।
definitely you have to come next
হ্যাঁ
time.
হ্যাঁ, আমি যাবো
At that
যাবো,
time
যাবো।
just you should assured earlier যে শশাঙ্ক এবার যাবো,
যাবো।
কিন্তু এবার কিন্তু আসতে হবে।
হ্যাঁ, শিওর। হ্যাঁ, নিশ্চয়ই। থ্যাংক ইউ। এই আমাকেও দিও ইউটিউব।
হ্যাঁ হ্যাঁ, পাঠিয়ে দেবো, পাঠিয়ে দেবো।
নিজের গলা কিরকম আসে একটু শুনি। আচ্ছা,
ঠিক আছে।
বাই।
ওকে স্যার, ভালো থাকবেন।
হ্যাঁ হ্যাঁ, টাটা,
শরীর ঠিক আছে?
টাটা।
ম্যাডামের শরীর এখন ঠিক আছে?
ম্যাডামের শরীর এবারও কাটতেই হবে। এই পরীক্ষাটা শেষ হচ্ছে এখন স্কুলে, তারপরে খাতা দেখাটা হয়ে গেলেই ডেট নিয়ে নেবো।
না, অপারেশনটা করিয়ে নিন স্যার।
অপারেশনটা করে নিতে হবে। এবার
হ্যাঁ,
হি রিয়ালাইজড যে অপারেশনটা দরকার, আর পাচ্ছে না।
ঠিক আছে, ঠিক আছে
ঠিক
স্যার,
আছে,
ভালো
ঠিক
থাকবেন সবাই।
হ্যাঁ,
থ্যাংক
হ্যাঁ,
ইউ।
হ্যাঁ, ভালো থাকবেন।
ঠিক আছে,
ওকে
ওকে।
স্যার, লিভ করছি তাহলে।
আচ্ছা, আমিও যাচ্ছি। ওকে।
হ্যাঁ।